Hey guys, welcome to day 4 of our mini challenge in collection framework. I am really happy to see your progress. Few of you are sharing your answers in the comments and few of you are sharing it in the community. Great to see that. I would also like to get questions from you so that the others will be benefited. You can either share it in the comments or in the community. Okay. What is there for our today's video? In today's video, let us learn about set interface and the implementation classes of set interface. As usual, at the end of the video, I will be sharing few tasks. Some of them might be easy. They are simple one-liners. Few of them you need to brainstorm. If you know any other questions other than this, I would always like you guys to share it in the group so that others also will be benefited. Okay. Now, let us get started. Okay, these are the topics that we are going to discuss now. What is set? What are the implementation classes of set interface? Few examples on HashSet, LinkedHashSet and TreeSet. What is set? Set is a sub-interface of collection. It is from java.util package. It is a type of collection which does not accept duplicates. Set has unordered collection, ordered collection and sorted collection. There is a point given over here which says that set does not accept duplicates. How will set know that this is a duplicate element? For this, set uses the help of hash code and equals method which are from object class. The type that you are using with set should override hash code and equals. As in, if you are working with the inbuilt classes like string, double, integer, boolean, character, all these inbuilt classes override hash code and equals. This is a contract which is used to check whether they are same objects or two different objects. So based on that, set can understand whether it is a duplicate element or not. Suppose say I am trying to add custom objects to my set. Just like how we have added to list implementation classes, if I try to add a custom object to set, even if they are same, as in I have got two employee objects with the same name, same city, set will add both the employee objects. Why? Because for set they are two different objects. Then how will I inform set that they are same objects? For that, you need to override hash code and equals in your employee object and specify with what property that you want to compare. Okay guys, while doing we will see that. Now let us look into the classes that implement set interface. They are HashSet, LinkedHashSet, TreeSet. HashSet is an unordered collection. LinkedHashSet is an ordered collection. The elements are ordered by insertion. TreeSet is a sorted collection. That is why I told set interface has all three different types of implementation. Now here, this is the pictorial representation. Together with that, my dear guys, there is also one other interface called as Navigable set. We will be using few methods of Navigable set while working with TreeSet. Now, let us get started with HashSet. HashSet is an unordered collection. Here, the elements are added based on the hash code value. HashSet can accept null values also. Guys, remember, in case of HashSet, the performance is faster because it doesn't have the work of checking for the index or sorting the elements. The elements are added faster using the hash code value. And also, the methods of HashSet are not synchronized. So, this is also an added advantage to increase the performance of HashSet. Let me show you a simple example. Here I have created a set and I have added few elements of type string. When you are trying to run it, see the output. The elements are in a random manner. They are added as per the hash code value. Guys, we will see the conceptual part first and then we will move on to the programmatic part. The next one is LinkedHashSet. It uses a hash table and a linked list to implement the set interface. Hash table is used for storing the elements. The elements will be stored based on the hash code value only. See, this class is a subclass of HashSet class. It means what? The elements will be stored based on the hash code value only. But in case of LinkedHashSet, it also uses a doubly linked list. It means the element will have a link to the previous element and to the next element. By this way, the order is maintained. That is why we are saying LinkedHashSet is ordered by insertion. It accepts one null value also. Let us see a simple example. Set is equal to new LinkedHashSet. I am adding few elements. If there are any duplicates will be removed because this is an implementation class of set interface. And the elements will be added as per the insertion order. You can see the output over there. The next one is TreeSet. TreeSet is a sorted collection. It implements sorted set interface. Sorted set is a sub-interface of set interface. Here, the elements are sorted by natural ordering. That is, either in alphabetical order or in ascending order. Suppose, if you are adding custom elements to your tree set, it is mandatory that you need to provide the sorting functionality. By default, tree set will not sort the custom objects. You need to provide by which property you want to sort the elements of your custom object. Suppose, if you are adding a list of employee objects to your tree set, you need to specify with what property you want to sort the employee objects. We will be learning about sorting in two different ways in the upcoming videos. Okay. Does TreeSet accept null value? No, because it has to do sorting. If you are trying to add null value, it will throw null pointer exception. And also, TreeSet will not allow non-compatible elements. What is the meaning of it? When we started with our example in array list, without adding generics, I tried to add different types of objects to our array list. It was working perfectly fine. If you try to do the same thing with TreeSet, immediately it will throw class cast exception. This is about TreeSet. Let me show you a simple example. Here I have given it as TreeSet. I have added few elements which are nothing but names. Here you can see the output. TreeSet is sorting the elements. There are many methods of TreeSet. While doing the program, I will explain you and I will show it to you. I want to show few methods of Navigable set also that is working together with TreeSet. Okay. Now let us see the examples. Let us create a new class. Select your package, right click, new class. We'll start with HashSet. So let me give the name as hash demo. Let me change the package name to set demos. Select public static void main, click finish. So let us create a HashSet object. HashSet is equal to new HashSet. Here I have given it as interface reference is equal to implementation class. It is also imported. Import set. Now add few elements to the set. HashSet.add Java. Let me add few course names. Together with this, let me also add null. Now let us try to print the set. HashSet. If you want to get the size, use the method dot size. Now let us run this. Here you can see the output. The elements are added as per the hash code value. Here also you can use iterator or for each to iterate the elements. List iterator is not available for set implementation classes. Okay. Now let us use iterator. Iterator string it is equal to HashSet dot iterator. You can see that method. If I just try to type list iterator, it is not available. Okay. So use iterator method. Then while it.hasNext. I have taken the content assist, string name, CISO name. Just print only the name. It is having null value. If you are trying to perform any operation on this name, that is name dot to uppercase, name dot to lowercase, it will throw null pointer exception. So be very careful with that. Now here it is printing the values. Okay. Now what will happen if I try to add duplicate values? Let us check that also. Let me run this. What is happening? Only one Java and one Angular is getting added. Here you cannot specify the order and you don't know which element is getting added because it is adding as per the hash code value. I hope this is clear. One more thing, let me also add a number within quotes. Here you will not see any difference because we are working with HashSet. The elements will be added as per the hash code value only. But I want to show you what will happen when we are working with LinkedHashSet and TreeSet. There is no order. Okay, fine. Now we will move on to LinkedHashSet. Now let me create a new class. This is for LinkedHashSet. I want the same data only. So what I can do is I'll copy this. Control C. Keep the cursor in the package. Control V. Let me give a different name. LinkedHashDemo. Let me open this. Now this time let us have a different name. Link. Control F. Replace it with link. Next. So the same elements whatever I have done for HashSet, I am adding it for LinkedHashSet. Here let me go and change it to LinkedHashSet. Shift Control O. Import it. Save and run it. Here the elements will be added as per the insertion order. See the output: Java, Spring, Angular, HTML, CSS, React. Java and Angular are already there. They are duplicate elements, so they will not be added. Finally, it is adding null and 100. Okay. The first case, it is as per the hash code value. There also it is as per the hash code value only. But because it is using a doubly linked list internally, the elements are added as per the insertion order. This also can accept only one null value. Two null values means what? Again it is a duplicate, right? Now we will move on to the next class, which is TreeSet. So again I will do the same process. Select your class, Control C, keep the cursor in the package, Control V. Let me give the class name as TreeDemo. Open TreeDemo. Okay, let me give the class name as TreeSet. Import TreeSet. The elements will be sorted and added. We will replace this. Control F. Replace it with tree. Replace all. Done. Okay. Now I told you TreeSet cannot accept null values, but still I am adding it. Let us see what is happening. Exception in thread main, null pointer exception. In which line? Line number 20. Let me click on this. Okay. I'll comment this and rerun it again. Now you can see here. Now the elements are sorted and added to the TreeSet. In which order it is adding? If you are having numbers within double quotes, first they will be added, then uppercase. Then it starts with first letter uppercase. Then it moves on to the lowercase elements. Okay. So the elements are sorted and added to TreeSet. Now let us see few more methods that are available in TreeSet. Whatever task I have given, based on this only you need to work, but still I will give you a hint so that it is easy for you to work with. Now let me click on TreeSet. TreeSet implements Navigable set. Let me click on Navigable set. Navigable set extends sorted set. So what is the hierarchy? The top level is collection, below which you are having set, below which you are having sorted set, below sorted set you are having navigable set, under navigable set you are having TreeSet. Okay. Navigable set was introduced only from 1.6. Sorted set is available from the earlier versions. So, whenever we are writing the hierarchy, we are talking only in terms of sorted set. But, my dear guys, there are so many methods that were introduced in navigable set which are very useful. What if I want to find the first element, the last element in a tree set? What if I want to get the elements lesser than a particular value, greater than a particular value? What if I want to find the element using ceiling and floor method? What if I want to find the element greater than the given value, lesser than the given value? For all this, navigable set has methods. TreeSet is implementing all those methods. Let me scroll down to show the methods. Lower, to return an element lower than this. Floor, to return an element lower than this or equal to this. Ceiling, to return an element greater than this or equal to this. Okay, higher, pole first. Already we have seen a similar method in queue interface, pole, peak. Here, pole first is used to retrieve and remove the first element. Pole last, retrieves and removes the last element. Iterator. Okay. When you are using tree set, the elements are sorted in alphabetical order or in ascending order. What if I want to have it in a reverse alphabetical order or descending order? It is having methods for that. There is a method called as descending iterator, with the help of which you can reverse the elements and print it. Okay, iterator. Descending set returns a reverse order view of the set. Okay, descending iterator. Okay, descending set will reverse the elements and it will return it to you. Descending iterator, whatever you have given, the same set will be maintained. It is going to iterate it in a reverse order and will print the values. Okay. Then subset. Just like a substring, here the method is subset. It returns a navigable set. Okay. Head set. Head set and tail set. These two are two interesting methods. Okay. Similar to pole first and pole last, we are having methods as remove first and remove last. Already we have learned when you are using pole, if the element is not available, it will return a special value. But these two fellows, they will throw no such element exception, because they are all from very older methods. Okay. And I told you there is a method called as reverse, which is used to reverse the elements and return a reversed set. Let us see all these methods one by one. Now let me go to tree demo. I don't want to mess up with this. Let us create a new example. Right click, new class. These are methods of navigable set. So I have given the class name as Navy demo. Select public static void main, click finish. So this time let us create a tree set of integer values. Set is equal to new tree set. Okay. Now guys, in the previous case, we were adding the elements one by one. There is also one other way of adding elements to a tree set. You can pass a collection within this. The collection can be a hash set, linked hash set, or array list or linked list. Now I want to create an array list and add the values of the array list to tree set. When we were working with the list interface, we explicitly added the elements one by one. There are two static methods through which you can create an array list with values. Let me show it to you. This is off the topic. The first method is arrays.asList. Most of you might be knowing it, within which I am going to pass integer values. See the return type of asList. It is list of object, because I have not yet started giving values. Let me pass two values. Now let me keep the cursor again here. Now see, it is changed to list of integer. Okay, let me add few values here. Okay, the return type is a list. List of integer numbers is equal to. And I can pass that as parameter in tree set. See here, it is taking collection as parameter. So I can pass numbers. You can directly pass arrays.asList also. This is one way of creating a list of values. There is one other method with the help of which you can create a list of values. The method is list.off. Again here it is returning me a list. list of angle bracket E. This method returns an unmodifiable list containing values. So this means if you are trying to add elements to this list, it will throw unsupported operation exception. Already we have learned that add method throws exception if you are trying to add elements to an immutable list or an unmodifiable list. So this way also you can add elements, list dot of 10, 20 likewise. Okay, let me comment this. Now my set is ready. Let us try to use the methods one by one. First let me print the set. Run it. The elements will be printed in ascending order. Next, I want to reverse the set. Dot reversed. This returns a navigable set. Okay. So let me create a tree set. Tree set is a subclass of navigable set. So I will create a tree set only. Reversed set is equal to set dot reversed. I forgot to add angle bracket here and I need to downcast it because the return type is navigable set, which is a super interface, and print that reversed set. Let me run this. Okay, the elements are reversed and printed. Now I want to print the first element. First plus set dot first. Okay, and print the last element. Set dot last. Now if I am using poll first, after printing the first element, it will remove that element. We will check it out here. So set, and after printing the last element, poll last. So set. Let me run this. Okay. After printing the first element, it is removing it. After printing the last element, it is removing the last element. Okay. Let us go in for the next method. Set dot descending set. This also is a navigable set only. Now I will get it over. Now I will get it in a TreeSet variable and downcast it. TreeSet. The return type is a navigable set. And CISO descending set. Run this. 99 is already removed. So here you can see the order is reversed. Just like how you have used reversed method, this is also doing the same operation only. In both the cases, you can return the data in another set. But what if I just want to iterate it? So in that case, I can use the method as set.descending iterator. This is only for viewing purpose. The other two, like it is returning a set itself. What is the return type in this case? It is iterator. It's equal to integer. Import iterator and use a while. We don't have to downcast it. We can print it directly. So number. So I hope it is clear. The first two cases, reversed and descending set, you are reversing the elements of the set and adding it to a new set. In the last case, only for viewing purpose, you are using descending iterator. Just like our list iterator. Okay, fine. Now, let us see about few more methods. Set dot ceiling. Now I have 50. Let me give 50. Let me keep the cursor here. See the description. Returns the least element in the set greater than or equal to 50. If 50 is available, it will return 50. If 50 is not available, it will give the next element greater than 50. Similarly, we will try floor also. I already have 50. So in both the cases, it will return only 50. Now I will change this to 51 and this also to 51. Now let us see the output. In the first case, it is returning 54. Above 50, the greater number is 54. So for ceiling, it is returning 54. The second case, floor, above 51, The immediate lower number is 50, so it is returning 50. If the same number is available, it will return that number, or else it will return the number lesser to it or greater to it. Now similar to this, they have got two more methods, higher and lower. Guys, I have given all these as task questions also. I want you to try it again there. Now here, let me give 50 and 50. Now let me change the method to higher and lower. See the description. Let me keep the cursor here. Returns the least element in the set strictly greater than the given element. In this case, even if the given element is available, it will give the element greater than that. In our case, we have 50. Even if 50 is available, it will give the value greater than that. So we will be getting 54. In ceiling, if 50 is available, it will return 50. Only if 50 is not available, it will go in for the immediate greater number. Okay, for lower also it is the same case. Let me run this. Greater than 50 is 54. So it is printing that. For lower, lesser than 50 is 34. I hope it is clear. Now, two more methods. The next two methods that we are going to see is head set and tail set. Okay. What is the purpose of it? This is very much useful when you are working with a list of string values or list of numbers. In our case, we are working with a list of numbers. If you notice, this is my list of numbers. I want to get the list of numbers lesser than 50. If you are working with array list, what you will have to do? You will be iterating through it. You will check if the number is lesser than 50. If so, you will be adding it to a temporary list and then you will return the temporary list. That's what we have been doing in the previous examples also. But now, in this case, it is enough. You convert your list into a tree set. Now we have already converted it into a tree set. The next step is use the method head set. Okay. See, there are two methods. The first method, if you are passing 50, it will return the numbers lesser than 50 that are available in this set. In the second case, but if I want to include 50 also, then I can move on to the next overloaded method. Here I need to pass boolean value as true, inclusive. Get the list of numbers which are lesser than or equal to 50. That's the meaning. First we will try this. See the return type, it is a sorted set. Now let me pass 50. This is returning a set. So let me print it directly. If you want, get it in a variable, iterate it using for each and you can print it. It is your choice. Suppose after getting the value, if you want to perform some other operation, that is after getting the numbers, I want to get the square of numbers means obviously I need to iterate it. The next one also let me add true. See the output. The last two lines. See how easy it is. If you are working with array list, you have to iterate through a list. Within that, you will be using a condition. If the number is lesser than 50, add it to a temporary list and then you will print the temporary list. Now in this case, what we have done? We have converted our list into a set. We are using TreeSet. So automatically the elements are sorted. Now we are using HashSet method so that we are getting the numbers lesser than the given number. I can use inclusive if I want to add that number also. Similarly, if I want to get all the numbers greater than the given number, then we can use tail set. So let me copy this method. This is bit different. If I am using tail set, it will return all the numbers that are equal to 50 and greater than 50. In the first case, by default, it will include 50. It means it will return the list of numbers that are equal to 50 and greater than 50. Now, I don't want to include 50 mean I can go in for the overloaded method and I will pass the second parameter as false. Now let me run this. So the first one is returning the list of numbers greater than or equal to 50. The second one is returning the list of numbers greater than 50. Okay. So I hope you have seen all the methods. Let me just check it out. Set dot add all, add first and add last, ceiling, clear. The purpose of clear is to remove all the elements from a set. You can use it with HashSet, LinkedHashSet and TreeSet. Then comparator we have not yet learned. Contains is just to check whether it is having the elements. Descending iterator we have seen. The return type is an iterator. It is only for viewing purpose. Descending set is used for returning a set in a reverse order. Then first we have seen floor. For each comes with stream. Get first, get last. Okay. Headset we have seen higher. Is empty is just to check if the list is empty. Iterator, last and lower. Okay. Yes. Poll first, poll last. Remove is to remove one single element. Remove all is to remove the complete list. Remove first. Yeah, these are all okay, fine. Reversed already we have seen. There is one other method called as subset. The subset is similar to substring in string class. But in case of subset, you will be passing the start index and end index. Correct? But here you need to pass the from element and the end element. That is two element. Remember, it is not the index, but you are passing the element value. And here also you are having inclusive and exclusive. From inclusive to inclusive. Whether the starting and the ending element should be added or not. Okay, I don't want to do that. You guys can try it out. Then there is one important method. How to convert your set into an array. The method is toArray, but it will return an object array. I am having a set which is having string values. I want to convert it into a string array only. How this can be done? Using toArray function, or you can use this one. The third method, third overloaded method. Okay, by passing the array name. This is a very important question. I want you guys to try it out. Now, what we have seen is with inbuilt types, that is integer and string. How to add custom objects to our set. Let us try it out. So, let me create a new class, empSetDemo, public static void main. I am going to work with the same employee class that we have been using in the previous session. So, we can import it here. Now, guys, first I will create a list. From the list, we will create the set. Okay. List of employees is equal to. Now, I need to create a list of employee object. We are not going to do it in this way. What we can do is, we can use arrays.asList method. Arrays.asList. Now, here I need to pass few employee objects. That employee objects, that I will copy it from this one. I will copy it and modify it. Okay. Now my list is ready. List of employee objects. Okay. I have used arrays.asList method. Now let us convert it into a set. Set of employee, empSet is equal to new HashSet. We will first try with HashSet. Angle bracket within which pass employees. Import all. Now let us print it. EMPL set. There is one extra. Let us also use a for each to iterate it and print it. So employee. Okay. Now let me just pull this down. Here you can see there is no order maintained because we are using HashSet. Now, instead of HashSet, let us try with LinkedHashSet. Okay, I am just changing the class name. Let me run it again. This time, the employee objects will be added as per the insertion order. Harry, Priya, David, Joseph, and John. Okay. Now what will happen if I try to use TreeSet? The moment I use TreeSet, it will get a confusion. It has to sort the elements before adding it to the set. But with what it will sort? Should I sort it with name, or with ID, or with city, or with department, or with salary? You have not specified anything. Then how it will sort? In this scenario, it will throw an exception. Now let me save this. Java.lang.class_cast_exception. Let me open the exception. Java.lang.class_cast_exception. Employee cannot be cast to class comparable. What exactly is the meaning of it? We have got our employee class, but we have not specified with what property the employee object should be sorted. If you want to perform this operation, you need to either use comparator or comparable interface. Let me just show you one simple thing. Here we have string. Let me click on string class. It implements comparable. That is why automatically the string elements are sorted in alphabetical order. Now, if I go to integer, it implements comparable. That is why the numbers are automatically getting ordered in ascending order. But in our case, our employee class is not implementing comparable. That is why set is not able to sort the employee objects. We will be learning about sorting in the upcoming videos. I hope this is clear. If you want to add custom objects to a set, it is very well possible if you are using HashSet or LinkedHashSet. You cannot use TreeSet. Whatever is needed for working with set, we have learned properly. Now it is task time. Let me open the task for today. Okay. Guys, I have categorized our task as basic and advanced. Okay. Whatever you have learned already together with me in the video, that only I have given. If you guys know any other questions, please share it in the comments. It will be very helpful for the others also. Okay. Now let me read the questions. Given a hash set with integer values, clone it to another set. There is a method called as clone. Convert your hash set into tree set. It is easy. Okay. When it is hash set, the elements will be in random order. When you are using tree set, the elements will be sorted and you can print them. Given a hash set with string names, create a reverse order view of the elements. I am not expecting a new set. I just want to print it in reverse order. Actually, what you can do is even you can reverse the names. Reverse the names and create a reverse order. Given a hash set, find the numbers less than 50, head set. Find the numbers greater than 50, tail set. Given a tree set of integer values, get the element which is greater than or equal to. Oh, sorry, this is tree set. Okay. Get the element which is greater than or equal to the given element, less than or equal to the given element, strictly greater than, strictly lesser than. Okay. Then reverse the set and print it. Then retrieve and remove the first element and last element. Then print the first and the last element of a tree set. In the first case, you will be using pole, last and okay, you just find it out. Write a program to remove duplicate strings from an array and store the unique strings in a hash set. Okay, these are few basic questions. Already we have dealt it in the video, but still for practice, you can try it out. In case of head set, tail set, rather than using numbers, you can create a set of string names, convert it into ASCII values, check which ASCII value is greater than a particular value. Based on that, you can return a string also. That is also a bit complex. Now moving on to the advanced question. Given two hash set of string with course names, web is equal to one list, full stack is equal to one list. Now what you need to do is compare both the sets, retain the elements that are same. Okay, so my output should be HTML and React. The second case, whatever elements are not common in both the set, you need to print that. Spring, Java and CSS. Next, write a program that reads a paragraph of text, splits it into words, uses a HashSet to count the number of distinct words. So this is my paragraph. I have to split it into words. Then I need to add it to a set. If I am adding it to a list, all the elements will be added. Java is fun dot, Java is powerful dot. What I want is only unique elements, so you need to add it to a set. Okay. So you have to use few methods of string also. My output should be Java is fun powerful. Write a program to group strings by their first letter using a TreeSet. So you have got a list. From this list, you need to create multiple TreeSets based on the names that are available. So group A into one set, group B into another set, group C into the third set, group D into fourth set likewise. Based on that, it has to create it. The next one, find the longest string from a set. Okay. And store all strings of the same length in a hash set. In our case, I have got Java, JavaScript, Python, Kotlin, React. JavaScript is the longest string, so you print it. Next, these three are strings with the same length. You put it in a separate set and you print it. Suppose similar to Java, if I am having SCSS, then I need to have another list or another set having Java and SCSS. Likewise, you should create multiple lists and print it. In the previous case, you were checking with the starting letter. In this case, you are checking for the length. Both are similar only. Write a program to remove all the strings from a hash set that start with a specific letter. So here I want to remove the elements that are starting with A. My final output should be banana and cherry. Guys, most of you would have done it using arrays when you are working with data structures and algorithms, right? When you are working with data structures. Now you are trying to do the same thing using set and list of Java. That is the only difference. I hope all these questions are clear. I'll share all these questions in the description box. Together with that, please do share your answers in the comments or join our community and share your answers there. Whichever is the way, I am eagerly waiting for your answers. Okay, guys, I have explained whatever is needed to work with set interface and the implementation classes of set. Now it is your duty that you need to complete the tasks. Only if you do the task, you will get a deeper understanding of working with set and set implementation classes. If you are having any other questions, any complex questions that are relevant to working with set or list, please do share it in the comments. Okay, once you have completed the tasks, please do share your answers also in the comments or join our private community. Whatever is the case, I am eagerly waiting for your answers. That way, I will also learn with you. As always, keep learning and stay curious. Let us learn, code and grow together. Thank you.